Hello, my name is Isaac Gilbert and I'm a particle characterization specialist at Analytik. Particle characterization is an essential tool for understanding the properties and stability of sample formulations. With a wide range of techniques available to measure and collect a vast amount of data, it can be difficult to understand which is most suitable for a particular application. No one method will give you everything you need. However, a range of complementary techniques can be used to gain a full understanding of sample characteristics. Differential centrifugal sedimentation, or DCS, can be used to analyze particle size distribution. The technique utilizes a modified version of Stokes' law to determine an unknown distribution of particle sizes by measuring the time it takes for particles to settle from a known distance in a liquid of known viscosity and density. This method allows for ultra-high resolution size measurements. Exposure to a high G-force through a centrifuge allows the sedimentation of even very small particles down to just a few nanometers in size to occur quickly, enabling real-time analysis. The CPS disk centrifuge allows the measurement of highly polydispersed particles within an approximate size range of 3 nanometers to 60 micron, depending on the particle density. The CPS can measure particles with as little as 2% size difference from one another. Rather than rely on a predictive algorithm, the CPS physically separates particles and measures them as they pass a light source detector for 2 to 10 times higher resolution than any other particle sizing instrument. Within the pharmaceutical industry, applications vary from analysis of virus and virus-like particles to gold and silver nanoparticles used in drug delivery systems. Nanotracking analysis, or NTA, is a widely adopted method of measuring particle size, concentration, and fluorescence. The versatile technique is capable of multi-parameter measurement for many types of particles, saving time and reducing required sample amounts. When concentration is of particular importance, NTA is the technique of choice. The ZetaView is a next-generation nanoparticle tracking analyzer that measures hydrodynamic particle size between 10 nanometers to 1,000 nanometers, concentration between 10 to the 5 to 10 to the 9 particles per mil, and also measuring zeta potential through the analysis of a video sequence at 11 separate positions in a flow cell. Each individual particle in the 3 nanoliter field of view is counted and tracked in short video clips, creating accurate and reproducible concentration calculations, particle size distributions. These parameters can be measured both in scattering mode and in fluorescence mode if the determination of fluorescently labeled subpopulations is of interest. Key applications include fluorescently labeled nanoparticles, extracellular vesicles and exosomes, drug delivery, liposomes, and virus-like particles. Streaming potential is used for determining the surface charge of nanoparticles in a colloidal solution. From this, zeta potential can be calculated. However, zeta potential alone is often insufficient to assess the true stability of a colloid or dispersion. Plus minus 30 millivolt is often quoted as a threshold for stability, but this is only relevant to the sample as it stands in that exact chemical environment. It is entirely possible for two samples to have minus 30 millivolt zeta potential but have very different stabilities. The stabilo allows us to determine true stability, as it tracks changes in zeta potential against volume of titrant added, allowing calculations such as isoelectric points to be calculated when performing a pH titration. The stabilo is a unique zeta potential instrument for analyzing and optimizing the stability of colloid and dispersions. It is able to measure sample concentrations from 0.01 to 40% in volume, with fast pH and polyelectrolyte titrations, providing ultra-high resolution zeta potential plots. It utilizes a unique mix and measure principle for continuous rapid mixing of the sample, preventing sedimentation, making it ideal for formulation development, particularly within the pharmaceutical industry, with key applications in areas such as drug delivery and liposomes. Dynamic light scattering, or DLS, is a widely used technique for determining the size distribution profile of small particles in suspensions or polymers in solution. Compared to NTA, particle size can be measured at higher concentrations up to 40% weight volume. The NanoFlex is a particle size distribution measurement system utilizing 180-degree heterodyne backscattering DLS. This technique allows for high resolution size measurement at highest possible concentration with reduced signal to noise compared to standard homodyne DLS. Using a highly flexible 5.5mm diameter DLS probe, the system allows for in-situ measurement of particle size distributions of suspensions and emulsions in the range of 0.3 nanometers to 10 micron. The NanoFlex is ideal for a range of applications, including colloid stability optimization, re-agglomeration control, core shell design, and dispersing efficiency development. For further information on any of our particle characterization solutions, please visit our website.